Hey everyone, so in this video we are going to build our own network monitor software, just like Wireshark. It's always good to have your own tool and see the working of how a software works and what data is sent and received at different layers of TCP/IP stack. So this software will capture all the data, network traffic, and for now it's just console based system, but we can enhance it to contain GUI as well. So that might be in a different video. So just let's get started with the program. So first of all, we are going to import the basic libraries. I'm using the Golang ID. You can use whatever ID you use. So obviously we use bytes, fmt, log, and then os, user, string conversion, and sync. Now besides these we need two other libraries. For now we will add the third one later on. So that will be github.com github.com/google, and there is the go packet, and I'm just going to copy it, and we will add the pcap as well. So let me just sync dependencies. All right, now the dependencies are synced, and the first function that we need to write is to check if this program is running as admin, because in order to monitor the network traffic we need to have access to the libpcap library or winpcap, whatever we are using, and that requires admin privileges in most cases. The function that we are going to write will be applicable to the Linux based system. I'm using Mac OS. Same will be applicable for Linux based, but for Windows this function will be a little bit different, which is not in the scope of this video, but you can simply run the function as the program as the admin in Windows, and you should be good to go. So what we are going to do is current user and error, and if not null, and we are going to use current user. Oops, it's not equal, I forgot. All right, so if error is not equal to nil, then if there is error, it means that if there is an error we are going to exit simply. So root unable to get current user, then we are going to just print the error. Otherwise we are going to return if current user dot username is equal to root. Now this is a very basic check. You can use different approaches as well, but for now we are going to just go with this one. The next function is our main function, and the first thing that we need to do is to get a list of all the interfaces present on the device. So we are going to do devices error equal to pcap dot find all devs, and if error is not equal to nil, we are going to just log, and again panic, and we will just print the error here. So that should be it. Now the next thing we need to do is to print these devices in the console. So I'm just going to print id space, let me just copy this whole thing, and name, and again. Now we are going to run a loop for id and device and equal to range devices, and in here we are going to print f, and again we are going to do this digit and string, and this will be id and device name, right? So because you click here and because this is int, so that's why we are going to do the digit here. So let's just define a variable here at the top. You know what, let's just define all the variables once, so that we don't have to use again and again. Obviously we will need the interface name, which will be empty for now. Then this will be a snap length. Now this is the maximum buffer size that we are going to capture. So you can define it whatever size you want, but I think 1600 should be more than enough. And when we are going to capture the network traffic, we can enable the promiscuous mode as well. Now promiscuous mode means that you can listen to all the network traffic in the network or just your own. So uh, we are just going to turn that to true. We will use that later on. Next we need the timeout. Timeout can be pcap dot block forever, so that we continuously get it. And the variable which we need at the moment is that whether the interface has been found or not. So that's just false, right? All right, so once we have defined this variable and we have printed this, we need to take the uh, input from the user. So this will be a string, and we are going to do fmt dot scan, and we are going to pass the input here. Right, so now we need to check whether this was the interface id entered was correct or not. So we are going to use string conversion dot atoe, and we are going to do input, and if error is not equal to nil, then we can just print and invalid interface selected, and just return from here. Oops, this will not be here, this will be invalid number, invalid id entered, because this will be here. So next we are going to check for id and device, and this will be again ranging devices. We will again run the loop here, range, right? So in here we will check if the id equal to number, and we will get the dev found is equal to true, and iface is equal to device dot name, right? Right, so next check we need to add if device is not found, then we are going to return simply here. So log dot panic, again invalid, whatever we want, invalid interface, simply that. And further on we can just print f interface as selected, and in here we can print the interface name, right? So as long as here we should be fine. Let me just comment this one, and this one, save it, and oops, we need and here, not my bad, right? So we can see that we have we are bad at formatting, so instead of here we are going to put a line break, clear this and run it. We have interface now my default interface is en0, so I'm going to enter it, and we can see that we have selected the en0 interface. So so far we are going good with that. So we are going to add a new line simply here. All right, now we are going to start capturing the network traffic. So from here we are going to do the handle, and error is equal to pcap open live. Now we are going to pass the iFace name as the device. Snap length we have already defined, promiscuous we have already defined, timeout as well. So this should be it. If error, my apologies if you hear some noise at the background, I'll try to cut that. So if there's issue here, so we will panic ln and error here, and continue with the execution. Now we are going to use the defer here, handle dot close. Now if you're not familiar with the defer keyword in Golang or the defer concept, it means that this line will be executed once the surrounding function has completed its execution. So once we are done capturing, then the handle will be closed. All right, so we have now successfully got the handle now, and now what we are going to do is we are going to use the source and go packet dot new packet source. We will pass the handle and handle dot link type, right? So now we are going to print here network traffic capture started, and now we are just need to print the packets here. So we are going to do the packet equals range source dot packets, and in here we can simply do the packet string. We can define it as packet dot dump. Now you can use the packet dot string as well, but there is a method packet dot string, but that does not dump all the information. So I prefer dump more than the string, and we are going to simply print ln packet string, right? So this should be it, I think. Yeah, that looks good. Let's clear the terminal, sudo go run main. We are going to select 0, and you see that we are now capturing the information successfully. So you see these are all the flags and all the packets that, if you are familiar with the Wireshark, then you should be able to recognize most of the information, because this looks same in the Wireshark as well. So we are going to stop it. Go. All right, so now let's enhance this program a little bit. Now obviously, if we have captured the information, we might want to broadcast it to a different system or whatever. So for now I'm going to create a WebSocket server in the same program, and then I will broadcast this information to the WebSocket client, so that we are able to retrieve this information from a different program as well. So what, before that let me introduce the filter part as well. So over here, before the close, and yes, and we are going to add a filter here. equal to handle dot they should be set bff filter, this one. And let's say that we want to capture only the TCP traffic and TCP based HTTPS traffic, so we can define different type of filters here. So for this purpose we are going to do TCP and port 443. And if again we if we have to check if there is an error, so error is not equal to nil, then we can panic here as well. It's a very weird name, by the way, panic. I don't know why they use it, but I encountered this word in Rust as well, but it's a weird name. Anyway, so we have filtered our traffic, and now only the HTTPS traffic should be captured. So again we are going to select it, and now all the HTTPS traffic is being captured. As you can see that destination port is 443 HTTPS. So this is how you can set your filters as well. Similarly, if you want to capture traffic from specific website or from specific clients or specific device in the network, that should be used for that purpose as well. So let me stop that, clear it, and now we are going to create a WebSocket server in this program, and we are going to use that. All right, so again let's add a new package, github.com. Oops, I don't know why I add these commas. We are going to add Gorilla WebSocket, right? And next thing we need to do is to define a variable called the upgrader, so that whenever we receive we receive a request, we have to upgrade it from HTTPS to WebSocket. So that's why an upgrader is required when using WebSockets. So we can do the read buffer size, buffer size 1024, right, buffer size 1024, and we have to allow the origins as well. So if you are familiar with the concept of origin, it means that which from which different type of websites or IPs, in roughly stated, which IPs can communicate with this web server. So for now we are going to allow all the IPs to connect with this server. So we are going to do boolean and return true. This should not be used in the production, by the way. I always mess up this, right? So this should be it. The upgrader is ready. Now next thing we need to do is we need to keep a check on the clients. We need to store all the clients that have connected to the WebSocket, so that we can broadcast message to a specific client or all the clients. And next we are going to create a mutex to log this variable. Now our mutex is also ready. Now next thing we need to do is to write a function, and this will be HTTP response writer, and this will be http.request, right. So the first thing that we need to do is to upgrade the request to WebSocket request. So upgrader dot upgrade, and w request is r, and header we can set to nil for now. Oops. Again, if error is not equal to nil, ft dot ln error upgrading and return. And if it has upgraded again, we are going to use the defer word here, connection closed, so that as soon as all the execution has completed, the connection should be closed. So now we are going to log using the mutex client. What should be clients here? Clients is equal to append. Now we are going to append obviously the clients and a new connection, whatever the new connection was received, and then unlock, right? All right, so now we are going to continuously listen for incoming messages. And error connection dot read message. If error is not equal to nil, again fmt dot println, we can say client disconnected, and here we can print the error and break the loop, right? All right, so next again we again log the mutex here, and as soon as the client has disconnected, obviously we need to remove it from the clients array. So we are going to use range clients if c is equal to on, clients is equal to append I, and clients gain I plus 1 and the expander, right? So this loop will remove the client from the clients list if it has disconnected, and again once this loop has completed, we need to unlock the mutex. So our WS handler is now ready. The next function we need to define is to broadcast. We are going to, for now we are going to broadcast the captured traffic to all the connected clients, but we can broadcast to a specific client as well, but for now we are just going to do the broadcast. So let's just broadcast message, and message, this will be string, right? All right, so again we are going to lock it to mutex defer mu.unlock, so that as soon as the message has been broadcasted, the mutex should be unlocked. Now for con range clients if error. Now for each client we are going to write message. So we are going to first define that it is a text message, and then byte, we are going to convert our message to byte. This is typecasting if you're not familiar with it. And if error is not equal to nil, then we are going to print the message that error sending message, and we are going to just print the error here, right? So this is our broadcast function, a very simple one. So now I think most of this is ready. The only thing that we need to do now is that we need to set up the WebSocket server and run it in a different Go routine, or in other words thread, so that it does not stops the execution of our remaining program. So if you're not familiar, the Go uses routines instead of threads. It's a bit of same concept, but routines are more lightweight than the threads in other languages. I forgot to call the isRoot function, which we defined earlier. That should be defined here. So we are going to just not an admin, simple message, and return. And down here we are going to call the http and handle function, and we're going to define the endpoint for the WebSocket, and this will be ws handler. Right now, next thing we need to do is to define a go routine. Go func, simple as that, fmt.println WebSocket server starting at port. We can define any port here, but I'm going to use the 444. And if error http.listen and serve, we are not going to use the TLS because we are not using the secure version, so simply web serve. And in here I'm going to define the address, and handler is nil for now. And if the error is not equal to nil, then we can print ln here that error starting the server, and print the error here. Right, so I think this should be fine and working. Looks good. And now let's try to run it. You know what, let's just oh, we forgot the main part. At the end, once we have captured the traffic, then we, instead of printing the message, we need to broadcast this message. So this will be packet string here, and for our own convenience we are going to print a dot every time a packet is received. So let's hope it works. So we are going to run it now. I'm going to enter the password. Now interface is selected, and now you see that the packets are being captured. Now let's I'm going to use the postman to connect to this WebSocket server and see if I can receive the traffic. So here is my postman. Right, so this will be the WebSocket server, and I'm going to connect it. And as soon as I connect it, I have started to receive the packets. Right, so if we go here, we are continuously receiving the captured traffic, and we are receiving all the data here. We can see that. So that's, I think that's it. We have successfully captured the network traffic using Go language, and we have also broadcasted it to a WebSocket server. Before ending, I think we can add another thing. Let's disconnect from here, and now that we have successfully captured the traffic, we can also add a check here that once it's dumped, now I'm going to get the app layer here, app layer, and packet dot application layer. Now this will get the data from the application layer, and if app layer, if there is no application layer data, then we are going to just continue. Next we get the payload from the application layer, app layer dot payload, and now we can add different checks here and scan for different data that is being transferred. So if, let's say, some client is using the HTTP version to communicate, or FTP version to communicate, and obviously when if he is using FTP, then the credentials will be transmitted in a plain text. Similarly, HTTP connections, the forms use a plain text to communicate the credentials, so that we can capture as well. For now I'm going to use a simple case that if bytes dot contains payload and byte uname, if bytes contain like this. Uname, here we can add pass user pass. So if any of this expression is matched, then we can fmt print ln string and payload, right? So if any of the traffic is exchanging the credentials, we can simply print those in console as well. You know what, instead of printing the payload in here, we can simply print the packet string because that would be easier to read. After this, we have to change our filter because right now we are only capturing the 443 traffic. So let's change this to 80 so that it captures all of the traffic of HTTP only. So let's run this. Sudo run main allow 0. The traffic capture has started. So this is a website which is HTTP by its design, and it's vulnerable, so that for testing purposes, and as we have opened this, we should be able to see these packets being captured. As you can see, only few packets have been captured because there is no other HTTP traffic. So let's go here and enter 123, press login, and even though our login has failed because the credentials are test and test, you can go back here and see that our traffic has been captured. And if we scroll down, we can see this part uname and pass 123. So similarly, if we were to enter the correct credentials, test and test, we are now logged in, and if we go back again, the actual credentials have been captured. So same is the case in the WebSocket client as well. We have captured this. So I think that should be it for this video. Most probably in the upcoming video we will try to set up a GUI for this software so that we can see something similar to the Wireshark and use different filters as well, and coloring scheme, so that to make it more usable for the normal user. But I think that's pretty much it today. If you have any question, please mention it in the comment. I'll be happy to answer, and thank you.